So now we're gonna import the other data we have exported. So for that, we're gonna save this test file, and with this type of logic, you can create different type of polygons. You can use it for creating floors, for creating walls, creating locational elements. So we're gonna make some intersections of things happening with it. So we're gonna save it. Can save it again as 02 test file end, which will be shared on the references of the file. Delete the settings on the level floor plan. So we're gonna get rid of the grids. We don't need the grids at the moment. And what we're gonna do is use the sprinkler network we have created to get things working around. So we're gonna start as well with the file system import to the file path. So we have several things happening in here. We have first the sprinklers, and we also need to read the sprinkler lines, and we want to have these sprinklers the pipe size. So we can mix and match these ones as we are required. So the path will be the file. Same thing we have done already with the grids and things. So this is called file path. Then we can go for the import, export, import Excel. Let's start with the sprinklers. Sheet name, it's gonna be summary. Summary, I think it's good. Yeah. Just remember to place it manually because otherwise it can loop forever. Read as a string, it's gonna be true. Show Excel false because we just want to have the values. So values have just position, it's the only one we're requiring. It's actually already in here, so that will make things much more easier. So same process we have already done. We're going to use rest of items. Then we're going to use transpose. And then we can use an A, apply its 2, 3, and 4. Actually, the 4 is not quite required because we're going to project. I will make it connecting like that. So having those points, let's see if they are already numbers. They are not numbers. The number they run and they are already in place. So let's think that they have already created this one on plan, and we have this type of structure. I'm just gonna move the elevation here, elevation here, and this elevation here. So let's place them structure like this thing. Sketch ceiling. So let's say that it's not that simple. It's just having a slope arrow from one point to the other one. And in this case, it has 1.2 meters. So it's having something like that. It's actually a little low for that. It's gonna make it much bigger. 5 meters. And I will make it better. And as well, we can add the floor. Adding a floor component. The location. So this one can be filled at 8 meters. No, it's much 9 meters. So we have a huge slope and the elements being placed within the plan. So modeling is not going to be just as simple as having a plan. So our first approach needs to be to get that type of geometry we're looking for, so we can go another Revit selection, select face. That's the case. And select it. And what will happen now is that we run it. We already have a surface that it's running, so if it's shared, it will look like this. Fine. Checking that we have the isolate. And the first thought is that those sprinklers need to be attached to that setting. So easy way out will be to project. The only problem with project is that the elements that we're running it, they need to be on the same location as the surface. So we wanted to make it to the surface. If they are out of the surface, we will have a problem because they won't project. So let me show you how does that will work using a vector. And actually it would be one because they're just projecting to top. And what we need here to happen is a lacing longer. So now they're actually projected on the way to the top. Okay, so now next to that, let's control the other elements we have from the files, because all of them will be connected so that a solution can be resolved. In this case, we have the sprinkler lines. Sprinkler lines as well need this type of management, so I'm just gonna copy this block. Yeah, it has two parts from files of that. And it's running, giving the lines and the settings. So it's gonna make different, little different location we want to have. Yeah, this as well. Now we need to have this one being picked up. Actual values from here it's 2, 3, and 7, 8. So 3, that's fine. And the other ones are gonna be 7, 8. So as you can see, same logic. We before reading simple elements of lines. Since we're running out of here, we're talking about lines. Let's get it by start point and end point. And that will bring something like this. That's the line structure we already have on our Then, but we need to separate them by using the same type of layers. So we can check for the layer value on number 5 and do that. Yeah, now it's separated by the type of element. So with that in mind, we need to have now separation of elements. We can use the group by key. The group by key function, what it will do is that if we get elements of at least keys with the same values, they will be sorted out as groups. So we have one group that is called the elements, the main, and the second one. So if we look at different groups, we can go A, yeah, it's the out of it. Runs. It's creating element as A. Multiple lines. Element as B. And element as C. So values will remain on the element, while what we try to get is locations being intersected, because we want to find the joints and the elements that will be colliding so that they are connected against 1, 2, or 3 elements. So because we need to do some collides, we are going to use the list join. We want them all lines to be together. So we're going to use both points to be connected. And we want to find collisions, so we can do it with spheres. So I'm gonna do another method that's by creating solid spheres. It's sphere by center point radius, so that if we have this radius of 1.15, I think that would be enough. If we look at hot elements that are having it like 0.15 and then checking if they are colliding with the other elements. We need to find a logic before we can make elements in the location we want. So if done properly, it will intersect elements and pieces so that they can collide. Third, we will need to use that one as well with the original geometry, not the final one, but the original here. Find the end lines. So we're using this one because we want to find with which element is colliding and where is the collections we want to find these systems, and then we can get the those intersect. So I will take a little because we are colliding this one with this one. It's to be cross product. So each line is showing a different number, but it's the location, I mean that it's the line that it's gonna be colliding with the other ones by using an index of, so we know that it needs to be a sprinkler connected to that line, and then the other line is going on the opposite side. So following the same logic, we find the intersects of the element within themselves. So what that will do is to find out how many times they are colliding with which element, so we can know where it's supposed to be an angle, a T, or another type of element. In doing that, we just also need to get the all indexes of. As we wanted to be all indexes of. And that will pull as well a lot of coincidences. So we can know that if there are three elements, that means that it's a T being created. If there are two elements, needs to be created an elbow with one element or the other one. So the easiest way to solve this one needs to be the unique items. Because that way we'll know how many lists are original. So we need to start by connecting the other line with the extreme of this one. So we have the unique items of 335, but we need to start thinking on how the geometry will connect when we have pieces of offsetting. So first of all, we're going to start with the sprinklers. The sprinklers have these numbers, so we can get them at index. So because our equation is going to be holding 157 points, start and end, if the value is greater, in this case, of 157, because if it's already 156, it will fit. We can use an if control. The if control is going to be really helpful for doing this flow going around. So it's going to be a minus 156. So 157 will be, so if the value is bigger, it will go with this true. If it's not, it's gonna hold with the false.
This is fine. So that is bringing all lines together, all the elements that are connecting. So since we wanted to be up from the projected element, we can also use that one as a distance going up. So for doing that, we need to get a little back. So we know which lines that we pick. So instead of selecting the lines, we can go for the start point. We can go for the end point. We will need to have the Z point. But there's a function that it's called change point C value. And what it does is change the points according to point Z to get. So we need at least two traffic because we don't want that line to be exactly at the same position as the sprinkler. So we can use traffic direction. Moving a little the element from its location, its predicted geometry. You see a flatten. Pick the right coordinates, and then we can collect direction, having it, let's say 1 meter up from the connection point. So that if we look closely, they can change point A to point Z. So we want to change this one with the geometry we have, but it's traveling 1 year, so we can make it 2 years. And without creating the line. So we can see here that the lines are now being placed up one layer for the element, and if we want to read it as well back, you can also connect this line depending on the value that it's having that connection. We should need to use this one as the if connector, so that if the number is smaller, it would use the first points. If it's not, it would use the last points.
changing the value and connecting the geometry to the other geometry. And yeah, we're gonna use the point resultant because it's gonna make it to be falling down because it's already at the same height. Even though that's illustrative, it's actually to fall because we want them to be connecting up. But it looks really good, right? It looks like you're getting elements out. Now we're missing to make this change, but not with the projected one, putting instead of the one that it's on the lower floor. So this will connect from here to the endpoint here. So result will look something like this. It's using a height of element. Yeah, it's actually on the opposite side because it's using the other one. It's creating like a Z value. So I just need to change this one. Yeah, just I think it's easier if you just make not by using a selection, but instead of using the connected elements to the projection itself, and I'm gonna make it lower 3.5. So the resume, it will go something like that. It's finding the pattern, it's finding the line, and it's doing all this construction on a rectangular basis, setting elements from the same path we were working at the beginning. So all of those elements are already thought in Revit way. And what we need is to separate and create the elements themselves. So finally, let's get into the last piece that we're missing. So in this case, we're trying to solve with the slope on the element, but the original drawing were to give two dimensions. So what I'm gonna do is gonna use the other values we have for the numbers, and then connect the grid with the lines so it can become an easy set for those elements already separated. So since we already have intersections, those are gonna help a lot. Where they are, it's yeah, here are the intersections. Those are gonna be really helpful. So for creating the lines, we don't need to have these ones split. We can just use the general lines. Can be fine with all of this. But what we need is actually the elements, the tags that we were using because we want to create it with the same logic. So if it's pulled from the file, so result is giving me as well the positions and the values. It's giving me the data that we want to get. So we can use the same type of coding, having the list of items set. Then we also can extract location points since all of them are on the same basis. So remember that if you have multiple levels, you can sort it like that. Number it's 2 and 3, that's fine. And number 5 is the one. Number 5 is the one that it's gonna give the values we are looking for. So let's run it. see whereabouts they are. There are several values on both. So the ones that we want is the ones that are with the percentage, because we want those sizes to be displayed. So let's get constraints. Search for, it's gonna be that percentage. And it's printing all true values, so we can get all indices of from the same time of finding information. We want the points and we want the data. Within the point, what we're gonna have is we can use an extrusion, an sphere being created from there with the same radius. Actually, in this case, it needs to be bigger, so we're gonna place it 0.3 radius. And then we can do a geometry intersect, but in this case, within the line. So it's gonna be the sphere with the lines we're using, so we can know which one is matching. All the strings we can use a string split. It's inspect. Yeah, it's split. It's a split. The separator we're gonna use, you get the price, is gonna be the percentage. And in that case, what will happen is that we will have the numbers and we will have the intersections, so we can know which pipe has which type of measurement. So once already run, it's splitting the values. So we only want the first value, get item of index, showing just the first value of the second list. And in the case of the geometry intersect, we need to find all indices of true. So that will make the number with the line that it needs to be matching. So we have the values, we have the lines, but we still will have some empty, and we also have several multiple elements. So depending on which one is the closest one, we can have something like first index of, or first item. So you can pick first item of that. And we'll need to get rid of the nulls before that. So if it's an empty, you can call it is empty. Traces of false. You can have a get hidden at index, so that it will pick only the ones that has an intersecting value that can also be applied from here. So we can have the elements, the lines, and the first values. And with those values, we can pick the lines for the elements. So the lines are here. If we run it again, it will clean out now the final result. So it will find those that has a number that it's intersecting with that element. So depending on how far the tag was for the element or how confusing it can become, it will take that information. So remember, it's not something that will have mistakes. It will depend on the process, but if it's a line that we're designing it in CAD, and then how you read just the scripts that you have already produced, you can use several methods I have already shown on this course. So we have finally 134 numerical values. And in this case, we can use a node that is called pipe. We have one that is pipe, create pipe by line and pipe, that is using net over mixed with practical in. So that we have those elements, in that case, it won't work because we need to have just the pipeline with the pipe element. We will use the same sizing. Yeah, we can have the pipelines. For the pipe element, we can go for Revit element. No, not element selection. For that element, select model element will be picked. So if we do it, it will be just pipe, generate pipe when we find. Yeah. So we can pick that one as a pipe element. Now we have a pipe element that's going to transform into a pipe element, but we're missing the size. So we can use the set parameter by name. And that's the negative trick because that will pull the lines, that will pull the elements and the other indices. It's actually called diameter. So it has already created the elements, but it's not following the diameter patterns that we want to have on the sizes that we already created. So we need to do it manually without its function. So the function is called from the net over with the package that you already installed. Use packaging. We'll give you net over. Then you go to the called Revit elements. Yeah, Revit elements called with pipe. The function is called pipe by line. So it's using the line. You can have the parameter by name, and the only difference in here is that instead of using the diameter, we'll bring the diameter from here. We need to have pipe from the selected element. So here, system type is actually not part type, it's type just system type, but really, it's gonna check it with the pipe itself. It's called system type, it's fine. And the level, it's called reference level. Setting rules a level, type, type, run. So we can review. Now we have the elements and they hold the sizes they were labeled on the file. So it can be used to create the elements within the proper settings. After that, start checking, using, or mix it with other tools. So as you can see, it's not a complete solution because it will depend on different workflows for creating MAPs. For creating architectural or structure, there's still the methods of intersection, of reviewing elements, of connecting, of using connectors and lines, importing the data extractions, the lines, and the Excel files are very useful for cleaning up the way things are working. Thank you for your patience. I hope you like it.